In this video, we're going to cover the heap section of the memory, and we're going to explain how it's actually used in Java. In the previous video, we talked about the stack. We gave examples of how the stack is used, but we didn't actually go over the heap, and the heap is actually pretty important as well. So as you recall, the stack is used to keep track of how the functions should be executed and in what order. But a heap is different. It's a resource. It's a bunch of vacant spaces that we can use, and we will explain why we need it right now. So we have, until now, mostly in our examples with memory, we have used int or float, and these types of variables are called primitives. And the reason they're called primitives is because they're the most simple types of variable that we can use, and they take very little space. So as we said, for example, an int only takes 2 bytes, or a float takes 4 bytes, again, depending on what programming language we're using. But the point is they're small and they don't take that much space. So when we create a function and we have, an int or a float and stuff like that, it's not a problem to put it in the stack because it takes little space. What we don't want to happen is the stack, instead of since it's a limited space, right? Because no matter how much RAM you have a section of the memory associated to the stack, a section associated to the heap, and a section associated to the code. So you want the stack to be responsible of the order the functions need to be executed. So the problem would become if we have very big variables, we don't want it to take this space. So and what are we talking about when we talk about big variables? So imagine if you define an array of 10,000 size, right? So if you say this is an array and it has 10,000 elements, and each element, we're saying assume an int is 2 bytes. Now there's 10,000 ints, so that's 20,000 bytes of space that's needed. So that's considered a big chunk of space. Also, whenever we define the class in our other sections of our videos, in a class you can define multiple variables, multiple functions, etc., and they all need space. So they're not like primitives where they only need 2 bytes and 4 bytes. So in that case, we use the heap. We use the heap to reserve space for bigger variables, and then we give the stack the address to that space, and we use that resource, and then we let it go. Keep that in your mind, and we'll do an example, and it'll make a lot more sense. So let me erase this. All right, so let's look at this example right here. We have a main function. We make a variable integer a equals 3, and then we call this function test function. And then in the test function, all we have is integer b equals 3, and then we have an array of size 5. So what happens when this function is put into the actual memory? So before we do that, every section in memory has a address associated with it, so we can reference it. Just like in the movies, when we reserve a seat, they tell us like go to seat 5A or go to seat 10D or something like that. They all have a label associated with it. So what we're going to do here in the heap, we're going to do the same thing. We're going to give each of them an address, and then let's say it starts from here. So let's say this is 10, and then this is 10A, 10B, and then let's say it goes all the way to F. And then again, this one will start at 11, and then 12, just like a movie theater as an example. So now we come here. If you recall, what's going to happen is this is going to get associated to the main function. And then inside of it, we have a primitive data type. So we have a, and we're going to just reserve the spot, use the memory for it here, and we're going to give it the value 3. And then it calls test function. So we again cut this part of the stack, and we're going to associate it to test function. So now we have b equals 3. So this is a primitive data type. So we're just going to assign 2 bytes to it right in the stack, give it the value 3. But then we have an array because C is an array, and we need 5 spaces for the int. So we're not going to reserve the spots in the stack anymore. What we're going to do instead is we're going to say C is here, and it has a size of 5. Now, if you recall, if you look at here in the B, we actually put the value, but for C, what we're going to do is we're going to give it the address of one of the seats or one of the spots in the heap. So we're going to say C equals 10A. So when the CPU, so right now our function, our code is successfully loaded into the stack. So what the CPU is going to do is it's going to come and see that, okay, I need to execute the test function. The value of B is 3, but the value of C, it's an array of size 5, and it starts from 10A. So it goes to 10A, and it starts to read the first 5 in a row. So it's going to read this one, this one, this one. So if this is D and this is E. So all the values of C are going to be in here because it starts at 10A and they're 5 and the size is 5. So it's A, B, C, D, and E. So 10A, 10B, 10C, 10D, and 10E, the CPU would know would be the array. And then it would read it, it would execute our code, and then it would be finished. Now the cool thing about the heap as well is that once the CPU is finished running the test function, Java automatically goes and frees up this space. So it will just empty this space that was occupied before because it knows that we're done with it. And therefore, that's the benefit of the heap. We can take some space, do whatever we need to do, and then release it. And that way we have a lot more memory to work with, and we're not taking the space of the stack, which is used for the execution of functions. And the way, if you haven't gotten it until now, the way you use the heap in Java is by using the new keyword. So whenever we're using new, whenever we're creating a class and we used to use new something, we're always, what that is telling Java is to reserve some spot for it in the heap. So every time you use new, that means you're using the heap, and it's good to understand that. And regarding the spaces becoming not being used anymore after you're finished, Java takes care of that itself. It's called garbage collection. In some languages like C++, for example, you have to do that yourself manually, but in Java it's done automatically, so you don't need to worry about it. But that's how heap is used and how Java uses heaps to run programs. I hope this makes sense. If any of it confuses you, I'll be happy to answer any questions in the comments. Thanks for watching. Peace.